Okay, so this is our second one about complex numbers. Let's get started with our paper. Let me put up the title. Complex numbers right here. Complex numbers, and this is the second one, so I'm going to put B. All right, let me go back to, let me put up the two most important things. There were four in the last one, but let me put up the two most important things that you need to remember. That I is equal to the square root of -1, and that I squared is equal to -1 itself. Those are the two most important. All four are important, but those are the two most important. Let's go back to the last problem that we did, because I don't think it was, I think I was running out of space and it didn't look good. So let me show it to you again. We had the last problem that we did in the previous video was a square root of -13. We said that it's pretty straightforward. You just turn it in 13. There's nothing to break into. I can't break it down into anything. It's a prime number. There's nothing I can break it down into. So leave 13 alone, but separate it into 13 and -1. -13 separated into 13 and -1. We know that the square root of -1 is going to be I. So what do I have so far? Square root of 13 and I. But on an answer sheet, it will probably not look like this. It will probably have I on the left and the square root of 13 on the right, and the problem is done. That is the previous problem from the previous video. So to make sure that that's clear and you can see it clearly. Okay, this moves us into slightly harder territory with these complex numbers. I don't think it's a big deal, but still it's different. It's a little harder. So we got it. We're talking about a multiplication now of trying to multiply two complex numbers. One is the square root of -9, and let me put a big dot here, and we're multiplying that times the square root of -25. I want to show you problem number 3 at the same time as you see problem number 2, so you can contrast the two. The problem number 3 is also a multiplication, but we'll have to deal with it differently. Give me a chance to explain. Problem number 3 is square root of -15 times the square root of -3. Hopefully we'll get to it soon, but first things first, but they should be up on the board at the same time so you can see the difference between the two of how to handle each one. They're both multiplications of imaginary numbers, but we need to handle them differently. Okay, so now don't forget the list of perfect squares. Perfect squares. Remember that list: 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, etc. The list of perfect squares. Try not to forget it. Okay, now notice over here, these number 9 and number 25 is on the list of perfect squares. That's in contrast to the other problem that we have to get to. There's no perfect squares there, so that's different. But here, our life is a little bit easier, probably. You might agree. This turns into the square root of 9 times the square root of -1. Square root of 9 times the square root of -1 is 3i. I don't need I on the right-hand side. 3i is good. I can stay on the, I'm sorry, I don't need it on the left-hand side. I can stay on the right because this is a regular number, whole number. Turn this into the square root of 25 square root of -1. Break it down into those two pieces. This then turns into 5i. Do not forget the following. What are we in the middle of? A multiplication. We're in the middle of a multiplication. So 3i times 5i is 15i squared. X times x is x squared. I times I is I squared. Now, you might say to yourselves, hey, we finished this problem. That's it. No. The reason I squared is equal to -1, we must take advantage of that. To finish this problem, we have to realize that this is the same thing as 15 times -1. I squared is -1. 15 times -1 is -15, and now we have finally finished this problem. The answer is -15. That is crucial. It's going to come up again. Okay, what about this problem? There's no 9 here, 25s here. Neither of these are perfect squares at all. What should we do here? Okay, so here's what we do. Break it down like we did. Square root of 15 and square root of -1. I'm going to do both of them at the same time. Square root of 3, square root of -1. what am I doing? Negative 1. Sorry. This is the square root of 15i. Square root of 15i times the square root times the square root of 3i. The square root of 15 times the square root of 3 is the square root of 45. I times I is I squared. Okay, very good. Now, let me go to scrap paper. Let me go to scrap paper. Be very careful here. Let me go to scrap paper. And we've got to figure out we've got to simplify the square root of 45. Remember that if we have square roots, we have radicals, we have to simplify them whenever we can. Is there a number on this list that you can break down 45 into and have another number and they'll multiply together and they'll get back to 45? Is there a number on this list of perfect squares? In other words, is there a factor of 45 that's a perfect square? The answer is yes. The answer is 9. 9 times 5. So the square root of 9 times square root of 5 is equal to the square root of 45. Square root of 9 is 3. And now we've simplified it. So what's really going on over here? We have 3 times the square root of 5 times what? Times negative 1. Because I squared is up there, negative 1. We can never miss that. So it's not the 3 square root of 5. It's minus 3 square root of 5. Minus 3 square root of 5 is the final answer. Very important question. Okay, now let's move the paper down, rather up. We don't have much space, but we do have a little space over here. I don't need a new paper yet. And I want to show you more about complex numbers. Complex numbers, let me show you right away a problem. It's problem number 1. I'm going to do start at 1 again. We're still dealing with complex numbers. That hasn't gone away. How would you handle minus 5 minus 3i plus 7 plus 8i? So we're dealing with addition and subtraction of complex numbers. Addition and subtraction of complex numbers. What's complex number? It's got a complex number has a regular component to it and an I component. Regular component to it, regular number, and an I component. Those are complex numbers. We've been dealing with complex numbers. I itself is a complex number. I itself is a complex number. In other words, if you have 0 plus I, that's equal to I, right? You got no number and I, it's equal to I. So a complex number has two parts to it. Sometimes it's 0. Or 52 plus 0i is equal just to plain 52, but they both go under the heading of complex numbers. All of this stuff can be, even a regular number can be called a complex number. You just have 0i. I can have a regular component of 0 and be equal to I. In any case, complex numbers come usually with two parts to it. A regular number and an I component. Regular number, an I component. The regular number is always on the left and the I component is always on the right. Regular number always on the left, I component always on the right. And we're dealing with addition and subtraction. What do you do? It's very simple. It's going to be anticlimactic. Minus 5 and 7. 7 minus 5 is 2. And minus 3i and 8i, so 8 minus 3 is 5, plus 5i, and this problem is over. That's it. You don't have to do anything more than that. Just add the two regular numbers together and add the two I components together. And you're done. You've got your answer. Okay, what if I gave you a little bit of a, just a longer problem? It's not really a harder problem. It's just a longer problem. What if I gave you minus 2 minus 4i plus 5 plus 2i, and then I put a minus in there. Then there's a 3 minus 6i. Okay, what's that minus going to do? Don't forget what a minus does. It does what it always does. It flips the signs of the members of the parentheses to its right. So 3 is going to turn into negative 3, and negative 6i is going to turn into positive 6i. So let me write all that out. We have minus 2 minus 4i plus 5 plus 2i minus, I'm not skipping any steps, minus 3 plus 6i. Now let's get all the like terms together, all the numbers together, and all the I components together. Minus 2 and 5 is 3. We can keep track of that in our head. 5 minus 2, that's 3. And 3 negative 3 is going to turn into a 0. Okay. Hold on, just bear with me. Negative 4i and positive 2i is going to be negative 2i. 4 minus 2 is 2, but you keep the sign of the larger, so it's negative 2i. And negative 2i and 6i is going to be 4i. So you're going to have 0 plus 4i. Let me do that another way. 6i and 2i, the two positives, are 8i. 8i minus 4i is 4i. What do you put on your answer sheet? They won't be looking for that 0. You just write 4i. Sometimes the number will disappear and all you have is an I, sometimes when you do an addition subtraction, and sometimes the I will disappear and all you have is a number. Same thing can happen in multiplications, which we have to see next. That the I can disappear and we have ourselves just a regular number. That can easily happen. That's where we need to go next. We need to be doing multiplying complex numbers. So I'm going to end this video here. I'm almost out of time anyway, and might as well go to the next video.